Hello students, welcome to Resonance Hyderabad CBC program. So today, as you know, we are discussing a worksheet for CBC 1 students, the first batch of students. So hope you are at home enjoying your vacation, and also appreciate you that you are giving little time in completing this worksheet also, in order not to increase the distance from your concepts which are taught in your classroom. We have come up with this worksheet discussion, right? So, and you have already known there are total 4 worksheets till May 31st. So today 24th May we are going to discuss the third worksheet, right? Now, third worksheet we are going to discuss under chemistry, right? So going to the first question, what is the number of atoms in 24 grams of carbon? In 24 grams of carbon, how many atoms are present? How many atoms are present? Very simple question. We know 12 gram carbon he is not mentioning any isotope, means normal, the most stable common isotope only you have to consider, like C12 isotope, right? So 12 grams of C12 isotope will be having 1 mole of atoms. 1 mole atoms is nothing but 6 into 10 to the power of 23 carbon atoms will be there, right? So in 12 grams itself, 6 into 10 to the power of 23 carbon atoms are present. Then in 24 grams, how many carbon atoms will be there? Double the number, na? So this will come to 2 into 6 into 10 to the power of 23. So this should be your answer, right? So 6 into 10 to the power of 23 wrong. 2 into 6 into 10 to the power of 23 perfect. Got it, na? So let's go to the next question. How many molecules are there in 34.2 grams of cane sugar? Cane sugar is nothing but sucrose. Sucrose is only commonly called as cane sugar, because in a cane sugar or sugarcane juice, the major or the most common component, the majority of the carbohydrate present is sucrose only. And sucrose molecular formula is also given C12H22O11, right? So first of all, let us calculate what is its gram molecular mass of C12H22O11. Gram molecular mass is the sum of GMM is the sum of GAMs of all atoms. All atoms. GAMs of all atoms. So it is 12 carbon atoms are there. Each carbon gram atomic mass or atomic mass is 12. So 12 into 12. So 120 plus 24. 144. 120 plus 24. 144 plus 144 plus how many hydrogens are there here? How many hydrogens are there here? 22 hydrogens, na? So that is each hydrogen 1 atomic mass, therefore 22 hydrogens are there, so 22. Then 11 oxygens are there. Each oxygen atomic mass is 16. So 16 into 11. 16 tens are 160. 160 plus 16, that is 176. So this comes to 6, 10, 12. Then 8, 9, 10, 14. Then 1, 2, 3. So 342 grams. 342 grams is the GMM. Gram molecular mass of sucrose, means this is the mass of, mass of 1 mole of sucrose molecules, right? So this 342 grams is 1 mole or Avogadro number, 6 into 10 to the power of 23 sucrose molecules, right? sucrose molecules. Hope you have understood. 342 grams of sucrose cane sugar will be having 1 mole of sucrose molecules or Avogadro number of sucrose molecules. Now he is asking in 34.2 grams how many sucrose molecules will be there. Then in 34.2 grams how many moles of sucrose will be there. 342 grams, if it is having 6 into 10 to the power of 23, 34.2 grams will be having 1 decimal to the left you have to take, that is 0.6 into 10 to the power of 23 sucrose molecules will be there, or else answer might be also given like this 6 into 10 to the power of 22. So this 10 to the power of minus 1 taken on this side, so 23 will decrease to 22. So either of them can be the answer here. So let's check what is given. 6 into 10 to the power of 23 wrong, 1.2 into 10 to the power of 23 wrong, 3 into 10 to the power of 22 wrong, 6 into 10 to the power of 22 is the perfect answer, right? So now let's go to third question. How many moles of electrons weigh 1 kg? Simple question he is asking. Each electron will be having certain mass, right? Like that, how many electrons you have to consider, you have to take so that all these electrons together will be weighing 1 kg, like 1 kg potato, 1 kg mirchi, right? 1 kg banana, 1 kg apple. In the similar manner, 1 kg electrons will be having how many electrons, right? We know 9.1 into 10 to the power of minus 31 kg. Do you remember what is this value? This is the mass of 1 electron, right? 9.1 into 10 to the power of minus 31 kg is the mass of 1 electron. So this much mass is of 1 electron. Then 1 kg mass will be having how many electrons? Just you have to do cross multiplication, 1 into 1 divided by 9.1 into 10 to the power of minus 31 kg. 31 electrons. Kg by kg will cancel, na? 31 electrons. So just you have to check whether the answer is given in calculated manner or as it is given, right? So 6 into 10 to the power of 23 wrong. 1 by 9.1 into 10 to the power of 31. 1 by 9.1 into 10 to the power of 31 is wrong. 10 to the power of minus 31 should be there, right? Then 6, 1 second. Yes, one more step is there in this question. He is not simply asking how many electrons are there. He is asking how many moles of electrons are there. So whatever total number of electrons you got, that you should divide by Avogadro number. Then you will be getting moles of electrons, right? So 6 into 10 to the power of 23 electrons is 1 mole electrons. Then 1 by 9.1 into 10 to the power of minus 31 electrons will be how many moles? This again cross multiplication, 1 by 9.1 into 10 to the power of minus 31 divided by again 6 into 10 to the power of 23. So this becomes minus 31 into 6 into 10 to the power of 23. Okay, na? So this becomes 10 to the power of minus 31, 10 to the power of 23. So if this is gone, you will be getting 10 to the power of 718. 10 to the power of minus 8. So final answer will be 1 by 9.1 into 6.022 into 10 to the power of minus 8 moles of electrons will be there. These many moles will be there in 1 kg of electrons. So now this is what I think it will be matching 1 by 9.1 into 6 into 10 to the power of minus 8. Perfect. So this is the answer. Understood? Anna? Now let's get into the next question. What is the molarity of water if its density is 1000 kg per meter cube? I hope even as I also have taught CBC in your regular classes, in some of your class, like in Chola, some classes I have taken. So to what I remember, we have not given molarity concept in CBC, but there are few questions came. I think 2 questions came with respect to molarity. So first let me explain what is a molarity, and then we will get into this question. Suppose I say, like I take 1 glass of water, right? And in 1 glass of water, let us fix the volume of water also. 1 liter of water I have taken, let us assume. In 1 liter of water, I have added 50 grams of sodium chloride. And in another beaker, I have taken again fresh water 1 liter, I added 100 grams of salt. Then in another beaker, third beaker, I took 1 liter of water and I added 200 grams of sodium chloride salt. So in first beaker, 50 grams, second beaker, 100 grams, third beaker, 200 grams, like this I have kept. I have made the solutions, salt solutions. Now, if anybody is asking, simply if I am asking you which solution will be more salty, then definitely you will say, right, as volume of water is kept constant, 1 liter, 1 liter, 1 liter only we have taken, and in all the 3 beakers we have taken 50, 100, 200 grams sodium chloride. So third beaker you will say that will be more salty, because more amount of sodium chloride salt is added in the fixed volume of water solution, right now. So you can say that beaker 3 is of more concentrated, beaker 1 is of least concentrated. Understanding the point? And beaker 2 is of a medium concentration. So this is one way, if you are saying according to amount of substance added per unit volume, you are giving it in terms of concentration, high concentration, low concentration. But if somebody is asking, you are saying in comparison to the second and first beaker, third beaker is more concentrated. But by how much concentration it is higher? To what intensity the concentration is more? Understanding? Suppose 2 bodies are given. One is a cold body and another one is a hot body, let us assume. Just we will take a thermometer like a scale and will measure. One is at 25 degrees Celsius, another one is at 35 degrees Celsius. You say that second body is hotter than the first body by 10 degrees Celsius. Understanding? But how you are able to say that second one is hotter by 10 degrees Celsius? You may know that it is hotter, but by 10 degrees Celsius, by how much it is hotter, you came to know by using thermometer scale. In the similar manner, here also you have to use some scale by which you can measure what is the concentration in first beaker, second beaker and third beaker. In measuring that concentrations, there are different terms, right? One of the term in measuring the concentrations of solutions is molarity, right? Molarity is there, molality is there, normality is there, mole fraction is there, mass by mass is there, mass by volume is there, volume by volume is there, ppm is there, ppb is there. Like that, so many concentration terms are there. But one of the concentration term you are coming across in this worksheet. So let me explain what is this molarity concentration term, and then we will get into the calculation also, right now. So hope you have understood. It is very simply, it is to measure how much concentration the solution is having, how much concentration the solution is having, without the generalized answers like high concentration, low concentration, medium concentration, little higher, little lower, like that. Exact concentration you can give. Understanding? So now coming to molarity, molarity is a term to define, to calculate concentration. Molarity is the ratio of number of moles of solute divided by volume of solution in liters. Volume of solution in liters. So what is the ratio you have to take? In the numerator you have to take a number of moles of solute, and in the denominator you have to take a volume of solution. Number of moles of solute to volume of solution in liters will give you what is the molarity of that solution. Maybe suppose 1 mole of solute is present in 1 liter of solution, 1 by 1 hai na? So this will be 1 molar solution. If 2 moles of solute is present in 1 liter of solution, it is 2 molar solution. If 1 mole is present in a 2 liters of solution, it is a 0.5 molar solution. So in this manner, you can calculate molarity if you know number of moles of solute and volume of solution in liters, right? Now, the same thing you can also write, this is a N by V liter, right? The same thing you can also write if you expand N, right? If you expand N I know N is a mass by molecular mass, right? Na? So, if I take N as mass by molecular mass into 1 by volume in liter, or I can also write it as M is equal to mass by molecular mass into 1000 by volume in ml. So, in any form we can write, in any form we can do the calculation, but it all depends upon in what way the data is given, in what units the data is provided to us. Accordingly we have to calculate it, right? So coming to molarity of water, if its density is 1000 kg per meter cube, 1000 kg per meter cube. Here one thing you have to understand, solute and solution. Solute and solution. What is solute solution difference? So that is a solute or solution if it is a binary, right? Binary solution is a solute plus solvent. Ternary solution, solute 1 plus solute 2 plus solvent. Understanding? Na? So in this manner solutions can be there, but here in this solution, what is solute? Water, because he is asking molarity of water itself, molarity of that solute itself, that component itself. So water is a solute, and what is a solvent? Solvent is also water. So simply he is asking what is the concentration of water, how many moles of water molecules are present in 1 liter of water, number of moles of water molecules present in 1 liter of water he is asking, right? So understand this definition. Molarity is number of moles of solute present in 1 liter solution. Here solution is water only and solute is also water only. So directly he is asking how many moles of water is present in 1 liter water. That ratio itself will be giving molarity. How many moles of water is present in 1 liter? Number of moles of water divided by 1 liter. So denominator is already 1. So if we can simply calculate how many moles of water is present in 1 liter, that number of moles itself will become the molarity of water. Understanding? Now from this data, can I find how many, what is this, can you identify? Kg per meter cube, mass by volume. Meter cube is volume units we have already discussed in the previous chapter. So this is kg by meter cube, that is a mass by volume. It is a density he has given. Density has been given. So this density 1000 meter cube, 1000 kg per meter cube. That means 1 meter cube will be weighing about 1000 kg, right? Then 1 decimeter cube will be weighing about 1 kg. 1 decimeter cube is nothing but 1 liter. So this is only we want 1 liter will be weighing 1 kg, right? Now number of moles of H2O is equal to mass divided by molar mass, right? What is the mass of a H2O? 1 kg, right? So 1000 divided by molar mass of H2O is 18. So 1000 by 18, if you calculate, it will come to 55.55 moles. So how many moles of water is present? How many moles of water is present in 1 liter solution? It is 55.55 moles. This 55.55 itself is the molarity also. So just if you want, you can take the screenshot also, because if I go to the next step, previous slide, this will be gone. Okay, na? So now 55.55 moles we got in 1 liter or 1 kg. 1 liter, 1 kg, because the density is 1000 kg per meter cube. So that is 1 kg per decimeter cube. That is density is 1. So going back to this point now, sorry, this only, na? So molarity is equal to number of moles of water, that is 55.55 moles divided by volume of solution, that is 1 liter. So that is 55.55 mole per liter, nothing but 55.55 molar. 55.55 molar. So the answer will come to 55.55. 5555, it will go on continuing. Therefore, after the decimal, the second number is rounded off to 6 here. Okay, na? So hope you have understood this one. And molarity also. One more question is there related to this concept. Molarity is number of moles of solute divided by volume of solution in liters. Volume of solution in liters. Or you can use these terms also. Okay. Or else I will write this in this way also. See, in whatever way we have taken here, in the similar way, if I write molarity is equal to number of moles of solute divided by volume in liters. So in this manner also we can consider. Okay, na? So chalo, let's go to the next question. How many molecules are present in 1 liter of water? This is what just now we have calculated. 1 liter water has 55.55 moles and molecules will be 55.55 into Avogadro number 6.022 or 23 into 10 to the power of 23 molecules, right? So this will be the answer, 55.55 into 6. You just calculate it, whichever option is matching, that will be the answer. 1 liter water he is asking. 1 liter water will be having 55.55 moles and each mole will be having 6 into 10 to the power of 23. Therefore, moles into Avogadro number will give total number of molecules. Total number of molecules. Okay, na? So going to the next question. What is the number of atoms in 56 grams of iron? 56 grams of iron. We know iron gram atomic mass. Iron gram atomic mass itself is 56 grams. Therefore, what you can understand is 56 grams is 1 mole is 6 into 10 to the power of 23 iron atoms. Easy enough? 6 into 10 to the power of 23 iron atoms should be present. 6 into 10 to the power of 23 iron atoms. Just he has given 56 grams means he has given 1 mole of iron atoms. Now going to the next question. how many moles are present in 392 grams of sulfuric acid. He is asking how many moles of sulfuric acid is present in 392 grams. First of all, let us calculate what is the molecular mass of sulfuric acid. Okay. So, 2, as the 2 hydrogens are there, each hydrogen 1 into 2 plus sulfur atomic mass is 32, each oxygen atomic mass is 16 into 4, 64, right, 64. So, this is 4, 8, 6, 3, 9. 98 is the atomic mass, sorry, molecular mass, or 98 grams is the gram molecular mass of sulfuric acid. Therefore, what you can say, as 98 grams makes 1 mole, 392 grams will make how many moles? So, that is 392 divided by 98. That becomes 4 moles. This is what I have done is simple. Number of moles is equal to mass by gram molecular mass. Mass given is 392 grams divided by gram molecular mass is 98 gram. Gram gets cancelled, you will be getting 4 moles. That's it. If he is asking a number of molecules, 4 into Avogadro number. Understanding? Next. What is it? Sorry, we have not tick marked the answer. This is 4 moles, first option. Then next question, what is the number of molecules in 44.8 grams or 8 liters of carbon dioxide at STP? We know 22.4 liter carbon dioxide at STP will be having Avogadro number of molecules, 6 into 10 to the power of 23 CO2 molecules. Yes or no? Because any gas at STP condition will be, any gas at STP condition 22.4 liters volume will be occupied by 1 mole. 1 mole is nothing but Avogadro number of that molecules, right? So, if 22.4 liters is having 6 into 10 to the power of 23 carbon dioxide molecules, then 44.8 liters will be having how much? So, that is 44.8 into 6 into 10 to the power of 23 divided by 22.4, once, twice. So, this is 2 into 6 into 10 to the power of 23 CO2 molecules. Understanding? 2 into 6 into 10 to the power of Jani? CO2 molecules, right? So, this is the answer that you can understand. Let's tick mark where it is present. 2 into 6 into 10 to the power of 23. This is the answer. Perfect, right? So, going to the next question now. How many atoms are present in 28 grams of carbon monoxide? How many atoms are present in 28 grams of carbon monoxide? Here, first of all, let us calculate how many moles of carbon monoxide are there, and then we will calculate how many atoms are present, right? We know carbon monoxide means molecular mass 12 plus 16, 28. 28 is the molecular mass of carbon monoxide. Therefore, what you can say, 28 grams, or let's see, like all we are writing in the similar way, right? Let us write in a different way now. Number of moles of carbon monoxide is equal to, number of moles of carbon monoxide is equal to mass divided by gram molecular mass, that is 28 grams divided by 28 grams. So, gram get cancelled, it will be 1 mole. 1 mole, so we are having 1 mole carbon monoxide, but he is asking how many atoms, Is he asking about carbon atoms or oxygen atoms? Which atoms he is asking? He has not mentioned. It means that he is asking about all the atoms together, right? In 1 mole carbon monoxide, we have 1 mole. If you divide this 1 mole carbon monoxide, if it is divided, we will be having 1 mole carbon plus 1 mole oxygen, right? 1 mole carbon is 6 into 10 to the power of 23 plus 1 mole oxygen atoms is also 6 into 10 to the power of 23. So altogether this will become 2 into 6 into 10 to the power of 23 atoms. You cannot say which atoms. All atoms together it is 2 into 6 into 10 to the power of 23. Total number of atoms are there. Suppose if he is asking number of carbon atoms, then it will be answer 6 into 10 to the power of 23 only. But he is just asking number of atoms. So this will become total number of atoms 2 into 6 into 10 to the power of 23. So that is 2 into 6, 12. 12 into, we don't have the answer here, I think, right? 12 into 10 to the power of 23 atoms. This should be the correct answer. This question, correct option is not there here. So we can take this as the answer here, right now? 12 into 10 to the power of 23 to be the correct atoms. Hope you have understood. Now let's move on to the next question. What is the number of atoms in 32 grams of oxygen? This is also same type. Most of the questions are of similar type. Mostly it all related to Y diagram only, right? So you can understand what is the importance of this concept, not only in this CBC, not only in the respective mole concept chapter, for the entire physical chemistry, and to get the confidence that you can handle chemistry comfortably. This concept Y map will be very crucial, right? So going to the 10th question, what is the number of atoms in 32 grams of O2? 32 grams of O2. Number of atoms he is asking. Again the same question you see. Number of atoms he is asking means the total number of atoms. First of all, 32 grams I will convert into moles, then into molecules, then into atoms, right? 32 grams O2 is nothing but 1 mole O2, right? 1 mole O2 is nothing but 6 into 10 to the power of 23 O2 molecules. And each molecule is having 2 atoms, therefore you can write it as 2 into 6 into 2 into 6 into 10 to the power of 23 oxygen atoms. So this is the answer for this question. Let's see, at least this is having the answer 12 into 10 to the power of 23. I hope this is also not having the answer, right? This should be the answer. 12 into, if this is kept, at least it should be given as 24, but this is also wrong. This is wrong. This is also wrong. 12 into 10 to the power of 23 should be the answer for this question, right? So going to the next question quickly. What is the mass of 1 electron? What is the mass of 1 electron? This is the fact based. You need not calculate here. So that is 9.1 into 10 to the power of minus 31 kg. So mass of electron, proton, neutron, then the charge of electron, proton, right? Relative charge to mass ratio. These all are fundamental information which we should know, right? So you have to memorize them. Periodic table also you have to memorize. By the time you come back to the campus, you should be perfect in most of these concepts. Almost all these concepts you should be perfect. So clearly you can see the difference between that student and you, right now? So that edge you will be definitely having in having the strong foundation, strong knowledge, grip on these concepts, right? So going to the next question. How many moles of NaOH are present in? This is what I was telling. One more question on molarity is this one. How many moles of NaOH are present in 200 ml of 0.5 molar NaOH solution? First of all, let me write the expression for molarity. Molarity is a number of moles by volume in liters. This can also be written as a number of moles by volume in liters. Number of moles, if you expand, we know N is equal to mass by gram molecular mass है ना. So if I substitute here, this will be mass by gram molecular mass into 1 by volume in liters. This also can be written as mass by gram molecular mass into 1000 by volume in ml. So these are all the different expressions. Now this is the third expression which will perfectly match to the data given in your question. Just to check it here. He has given, no, this is also not required. The required expression here is in another way he has given. That is a number of moles he kept it constant, but a volume he has given in ml. So that can be molarity is equal to N by volume in ml into 1000. So this is the expression which will be matching to you, to your question data, right? Now molarity is equal to how many moles are there? That is what we have to calculate, right? So now how much is the molarity? 0.5 na? 0.5 molar is equal to number of moles divided by volume of solution 200 ml into 1000. First of all, 200 ones, 200 fives, right? So, and 0.5 ones, tens. So, n is equal to 1 by 10. That is n is equal to 0.1. Right? So 0.1 is what? This answer. Got a point? Now going to the next question, interesting one. What is the number of protons in 1 mole of H2O molecules? In 1 mole of H2O molecule, you are given with 1 mole of H2O molecules. 1 H2O molecule has how many protons? Tell me. 1 H2O molecule will have how many protons? Then we will calculate in 1 mole how many protons are there. In 1 molecule, in one single molecule is given to you. In 1 molecule, how many protons will be there? In each hydrogen, 1 proton will be there. Then in oxygen, there are atomic number is 8. Na? So number of protons is equal to atomic number. So 8 protons will be there. So total 10 protons per molecule. In 1 molecule, 10 protons are present. In 1 molecule, 10 protons are present. Then, in Avogadro number of molecules, 6 into 10 to the power of 23 molecules, how many protons will be there? This is a cross multiplication. 6 into 10 to the power of 23 into 10 divided by 1, right? In 1 molecule, 10 protons. In Avogadro number of molecules, how many protons are there? So 6 into 10 to the power of 23 into 10 divided by 1, right? So these many protons should be present. So that is a 6 into 10 to the power of 24 protons per mole. This is the answer per mole, right? 6 into 10 to the power of 24. Perfect. First option itself is a matching. 6.022 into 10 to the power of 24. Now going to the next question. How many valence electrons are present in 1 mole sodium atoms? 1 sodium atom has how many valence electrons? What are valence electrons? First of all, valence electrons are the electrons present in a valence shell. Valence shell is the last shell, right? So if we take a sodium atomic number is 11, right? So 1s2, 2s2, 2p6, 3s1. Third shell is the valence shell here. In third shell, there are 1 electron. There is 1 electron. Therefore, each atom will be having, 1 sodium atom will be having 1 valence electron. 1 sodium atom has one sodium atom has how many valence electrons? 1 electron. Then 1 mole means Avogadro number of sodium atoms will have 0.622 into 10 to the power of 23 sodium atoms will be having that many valence electrons only, because each atom has 1 electron. How many atoms are there? That many valence electrons will be there. 6.022 into 10 to the power of 23 valence electrons. This is our answer. 6.022 into 10 to the power of 23 valence electrons. Right now, going to the next question. How many atoms are present in 1.8 grams of water? 1.8 grams of water. First of all, number of moles, let us calculate. Mass by mass of water divided by gram molecular mass. Mass of water given is 1.8 grams divided by gram molecular mass of water is 18. So, this becomes 10, 1 by 10, that is 0.1 mole, right? 0.1 moles. So, number of atoms, each H2O molecule has how many atoms? 2 hydrogens and 1 oxygen atom. He is not asking about only hydrogen or only oxygen. In general, he is asking how many atoms are present. So, altogether we have to consider each H2O molecule has 3 atoms, 2 hydrogens and 1 oxygen. Then 0.1 mole means how much? 6.022 into 10 to the power of 22 H2O molecules, right? So, this is a simple only, everybody might understood. So, one molecule if it is having 3 atoms, then 6.022 into 10 to the power of 22 molecules will have how many atoms? Again 3 into 6.022 into 10 to the power of 22 atoms in total. This is our answer. 3 into 6.022 into 10 to the power of 22. Or else he has given in this form, that is, this can be written in another way also, 0.6 into 10 to the power of 23. 0.6 into 10 to the power of 23, that is 3 into 0.6 into 10 to the power of 23. So, how much this will come to? 0.6 into 3, that is 8 in 1.8 into 10 to the power of 23 atoms. Ah, 1.8 into 10 to the power of 23 atoms. This is matching to option 2. If only hydrogen atoms he is asking, this will be the answer. These many hydrogen atoms are there, and these many oxygen, these many oxygen atoms are there, and these many total atoms are there. Total atoms are there, right now? 1.8 into 10 to the power of 23 total atoms. How many molecules are present in 5.6 liters of N2 gas? Very simple. N2, first of all, volume given 5.6 liters divided by we know 22.4 liters. So, 5.6 ones 4s. So, this is 4 only, na? 526 3 is 80, 6 4 is 24, 2.4. Yes, 1 by 4, nothing but 0.25 mole. 0.25 mole, right now? Now, he is asking in 0.25 moles how many molecules will be there, right? Just number of molecules. Total number of molecules is equal to 0.25 divided into Avogadro number, 6 into 10 to the power of 23 molecules. Right? Total number of molecules is number of moles into Avogadro number, or else if you want, I will write that also, expression also, see, for students who are not able to understand directly, number of moles into Avogadro number, right? So, number of moles here we got is 0.25 into Avogadro number is 6 into 10 to the power of 23 molecules. This is nothing but 1.5 into 10 to the power of 23 molecules. This is the answer, 1.5 into 10 to the power of 23. Perfect answer, option 2. Right now, so going to the next question, which has the highest number of atoms? Which has the highest number of atoms? First one, 18 grams water means 1 mole, right? 1 mole, and 1 mole molecules it is. 1 mole molecules will be having how many moles atoms? 2 moles hydrogen atoms and 1 mole oxygen atom, 2 plus 1, 3 moles. 3 mole total atoms will be there. Three moles total atoms are there. Then second one, 22 grams of carbon dioxide. 22 grams of carbon dioxide means how many moles? 0.5 moles, na? 0.5 mole CO2 molecules. Then each CO2 molecule has 3 molecules. Therefore, total number of atoms will be 0.5 into 3. That is 1.5 mole total atoms. Right? Then coming to third option, 6 into 10 to the power of 23 molecules of O2. Right? So, 6 into 10 to the power of 23 molecules means 1 mole. 1 mole O2 molecules. And each molecule has a 2. Therefore, 2 into 1. That is a 2 mole oxygen atoms. Then fourth option, 34 grams of ammonia. Ammonia we know, ammonia nitrogen is 14 plus each hydrogen is 3. So, total 17 is the molecular mass of ammonia. So, 34 grams is given, double is given, that means 2 mole NH3 molecules we are having. If 2 moles NH3 molecules are there and each molecule itself has 4 atoms, right? So, 4 into 2, 8 mole total atoms are present. So, which is having highest number of atoms? 3 moles here, 3 moles atoms, 1.5 moles atoms, 2 moles atoms and 8 moles atoms are present. Nitrogen plus hydrogen together, nitrogen plus hydrogen together. Therefore, fourth one will become the perfect answer. Perfect answer. Right now? So, hope you have understood this question also. Now, going to the next one, 18. Find the number of moles or moles in 0.5 grams of calcium. This is simple only. Number of moles, N is equal to weight by molecular weight, right? Or mass by gram molecular mass. What is the mass given? 0.5 grams divided by gram molecular mass is 40. So, how much this will come to? That will be the answer. 0.5 means 5 into 10 to the power of minus 1 by 40. 5 ones are 8s are. So, 8 means 0.125 and 0.125 into 10 to the power of minus 1. That becomes 0.0125. His answer is there? Yes. 0.0125. This will be the answer. Perfect answer. The 19th question, how many protons are present? This type of question already we got. In one molecule, how many protons are there just to calculate, then in total number of molecules, how many protons are there can be easily calculated, right? So, in one molecule, how many protons will be there? In one molecule, how many protons will be there? H2SO4 na? From hydrogens Each hydrogen 1, therefore 2. Sulfur atomic number 16. Oxygen atomic number 8. 8 into 4, 32 plus 16 plus 2. So that is a 10, 5. So 50 protons are present in each molecule. 50 protons are present in each molecule. Like that, how many molecules are given? 1 mole are given. 1 mole means Avogadro number of molecules are given. 6.022, then in 6.022 into 10 to the power of 23 molecules, altogether how many protons are present? That is 6.022 into 50 into 10 to the power of 23 protons. So where is this answer? 6.022 into 50. 6.022 into 50 into 10 to the power of 23 is also matching. Fourth option is the answer for this question. So going to the next one, number of neutrons in 1 mole of oxygen 16. Number of neutrons in 1 mole of oxygen 16, O16, same as protons only. These are all similar type of questions they have added. Each molecule of O16 has 8 neutrons. Each atom has, not molecule, each atom of O16 has 8 neutrons. Then 6.022 into 10 to the power of 23 atoms will have 8 into 6.022 into 10 to the power of 23 neutrons. 8 into 6.022 into 10 to the power of 23 neutrons. This is the answer. Right? So going to the next question. Oxidation. Yes. Good that the concept has changed. A lot of questions doing in a similar manner will make it boring. Yes or no? So I hope you also felt boring. So now oxidation number of manganese in KMnO4 is, we know the sum of oxidation numbers of all the atoms in a molecule will be equal to charge of that molecule. Charge of the molecule is obviously 0, right? So we know here potassium alkali metal always will be having a oxidation number of +1, plus manganese only he is asking, so I will consider it as X, plus each oxidation number is a -2 into, like that 4 oxygens are there, altogether it is 0. Understanding this point, now 1 plus X minus 8 is equal 0, X minus 7 is equal 0, X is equal to +7. This is what he is asking, right? So +7, this is the answer. KMnO4 means potassium permanganate, a very strong oxidizing agent, right? So going to the next question, what is the oxidation number of chromium in CrO2, Cr2O7 2-? Dichromate. The name of this species is dichromate. Dichromate. So in a dichromate species, what is the oxidation state of chromium he is asking. Already I told you this point, the sum of oxidation numbers of all the atoms in the ion will be equal to charge of that ion, right? So chromium oxidation number only he is asking, so I will consider it as X, therefore 2X plus -2 into 7 is equal to overall charge -2. So 2X minus 14 is equal to -2, 2X is equal to -14 goes on that side, right side, plus 14 minus 2 plus 12. So X is equal to +6. +6 is the oxidation state of chromium in dichromate ion. The next, oxidation number of nitrogen in NH4 plus. Oxidation number of nitrogen in NH4 plus. In NH4 plus, nitrogen will be considered as X plus +1 into 4, sorry, plus 1 into 4. Is equal to plus 1. So, x plus 4 is equal to plus 1, then x is equal to minus 3. X is equal to minus 3. So, where is minus 3 here? First option. First option is minus 3, right? So, going to the next question, oxidation number of chlorine in ClO3 minus. So, in ClO3 minus, ClO3 minus, this is chlorate. You are CBC 1 students only, right? You already have completed BIN chapter. So, in that it is already mentioned like OCl minus hypochlorite, in which oxidation number of chlorine is plus 1. Then ClO2 minus is chloride, in which chlorine oxidation number is plus 3. Then ClO3 minus chlorate, in which chlorine oxidation number is plus 5. And ClO4 minus, this is a perchlorate, in which chlorine oxidation number is plus 7. Plus 1, plus 3, plus 5, plus 7, right? All alternate oxidation numbers. Now, in ClO3 minus, he is asking oxidation number, that is a plus 5 only. Plus 5 only. But or else if you want to write in a systematic manner, you want to calculate x plus minus 2 into 3 is equal to minus 1. X minus 6 is equal to minus 1. X is equal to minus 1 plus 6. X is equal to plus 5. This will be the answer, right? So, that is the one. And coming to the last question, what is the oxidation number of sulfur in sulfuric acid? Same routine question. Sulfuric acid, here two compounds are there. If you remember, H2SO3, H2SO4, right? H2SO4 is a sulfurous acid because the sulfur is in lower oxidation state. If you remember in the BIN, we have discussed this rules, right? Sulfurous acid, and H2SO4 is sulfuric acid, right? As acid, as word will come when it is of lower oxidation state, and eq will come when it is of higher oxidation state. So, coming back to H2SO4, in H2SO4 it is a neutral molecule, so overall charge is 0, plus 1 into 2 for hydrogens plus x plus minus 2 into 4 is equal to 0. So, plus 1 into 2 plus 2, right? 2 plus x minus 8 is equal to 0. X minus 6 is equal to 0. X is equal to plus 6. So, this is the oxidation number of sulfur in sulfuric acid, plus 6, this one. Right. So, hope you have understood all the 25 questions we have discussed today, right? And you will be having a next class as physics, and this is worksheet 3. You will be having one more worksheet discussion on 31st May. That will be the last one. After that, you will be having whatever the regular classes are there, that will be there. And if any doubts are there in the worksheet we have discussed today, you can reach me out in WhatsApp, right? As other students, CBC students are asking their doubts, being at home, little 1 or 2 hours per day preparation is sufficient. And if you are having any doubt during this preparation, you can message me through WhatsApp, and in my free time, I will be sending you back the solutions, right? So this is my number, WhatsApp number. You can send the doubts. And now physics class at 10:20, right? So you will be having a break here. So we can, you will be having a break here. You can take the break, have your breakfast, whatever it is, and come on time back for the physics class. Okay. Thank you. All the best.
Ready, sir? That one I don't need, sir. Good morning to all of you. I have already discussed 2 worksheets. Now, today we will be discussing about 3rd worksheet, which is on work, power and energy. Some basic fundamental concept you need for doing worksheet 3. In that, first you consider what is work done. Suppose I have a body, okay, no? And you are exerting a force. Suppose this body has mass m and you are exerting a force. It is on a horizontal surface. Simple example. If suppose even after exerting the force, mass is not moving, then there will be no work done. If there is some displacement, then you can say that work would be done under one condition, that there must be a component of force either along the direction of displacement or opposite to the direction of displacement. There must be a component of force along the direction of displacement. You consider that work done to be positive. If there is a component of force opposite to the direction of displacement, you are telling that work done is negative, right? In simple way, you can say that work done is dot product of force and displacement. If you consider displacement in this side S and F is also acting in this direction, then simply it is product of force and displacement. But suppose I have body, you have exerted force in this way and displacement is in this direction, means force is exerted at an angle theta to displacement, then your work done is F dot S, means mod F mod S cos theta. Clear to you? If force is constant, then it is Fs cos theta. If force is not constant, then what will you do? You will be taking dW, and dW will be F dot ds, and then you will have to integrate F dot ds. Clear to you? Now, if you are considering this, then 3 different types of work done you are considering. In brief, just I am revising, already you have started doing the worksheet. Positive work done, 0 work done, negative work done. You have told if there is a component of force along the direction of displacement, then if you take 4 quadrants in this way, then in this quadrant or in this quadrant, if the value of theta is there, there must be a component of force. It means that if the angle between vector force and displacement is in between 0 and 90 degree. 0 included, 90 degree not included. Or it is in between 270 degree and 360 degree, first and fourth quadrant. 90 degree not included, 270 degree not included. Then you take any angle in first and fourth quadrant, your work done is positive. If theta is 90 degree or 270 degree, you know cos 90 0, cos 270 0. That is, if force is acting at right angle to displacement, your work done is 0. Clear to you? And go to second quadrant and third quadrant. In that, theta not including 90 degree or 270 degree. If theta is in between 90 degree to 270 degree, this total you take not including 90 and 270, then there will be a component of force opposite to the direction of displacement. Then you consider work done to be negative. I have a very simple technique. Suppose you do any work and someone is helping you, yeah, then work done is positive. Okay, no? Someone is resisting, opposing. Three situations I am taking. Suppose I have a body. This is a body and I am taking it up. Gravitational force will resist, will oppose. Because someone is resisting you, you take work done to be positive. If I am taking this body and moving it downward, gravitational force is helping me, then work done will be negative. Resistance, assistance. Resistance, work done positive. Assistance, work done negative. While doing work, there is no resistance, no assistance, then work done is 0. I am considering just like this. Okay, now, due to that reason, when you are taking energy of an electron in any orbit of an atom, your energy is negative. For example, in hydrogen atom, you take energy of electron in the first orbit, you are telling minus 13.6 electron volt. Why? When you are going to infinity and you are bringing one electron from infinity to first orbit of hydrogen atom, your work done is negative. Okay, but if you take any positive charge and bring in any electric field due to a positively charged body, there will be resistance, your work done will be positive. Clear to you? If you understood this, then further as problems will come, I will be going on giving you some more concept. For example, potential energy, mgh you are considering, kinetic energy, half mv square you are taking. Linear momentum, if it is p, then kinetic energy will be equal to p square by 2m. That one also you will be considering while solving the problems. Let us start now worksheet number 3. Number 1. Which of the following conditions must be true for work to be done? Just now I have told you, for doing mechanical work on any body, you need two things. There must be some net external force acting on the body. And there should be some displacement either along the direction of application of force or opposite to the direction of application of force. There must be some component. Let us see what answers they have given you. A force must act on a body. Yes, a force should act. The body must move. Yeah, body should be moving. Then only there will be displacement. The force and displacement must have a component in the same direction. This is also true. What will be the answer? They are asking you conditions for work done. Partially, you take 1 is right, 2 is right, 3 is right. Your answer will be all of the above. So your answer is number 4. Clear na? Let us move to next question. What is the work done when a person is holding a 10 kilogram object stationary at shoulder height for 5 minutes? You take some object and you are keeping on the shoulder. Is there any displacement? No displacement. And just now I told for work done, F dot S. When S is not there, if displacement is not there, will there be work done? There will be no work done. So what is work done when a person is holding 10 kilogram object? Really muscles, okay, no, will have to do work in holding that. You will be tired. Okay, no. A very simple logic I have found. If a simple plain glass of water, 200 milliliter, hold in hand, for 2 minutes you will not feel pain. 10 minutes, your hand will start paining. Half an hour, you will be fully tired. Right now? But here, in the language of physics, if you want to do mechanical work, there must be displacement. So what will be answer for this question? Answer will be 0 joule because there is no displacement at all. Let us move to next question. A force of 10 Newton is applied on a body at 90 degree to its direction of motion. What is work done? Just now I told you 3 different types of work done. Positive work done, negative work done, zero work done. For zero work done, what I have told you, the angle between force and displacement should be 90 degree or 270 degree. Already they say you, here force is acting at 90 degree to displacement. Cos 90, 0. How much work will be done? 0. So answer for this question is number 3 because theta is 90 degree, work done mod F mod S cos theta. Clear to you? Let us move to next question number 4. If the angle between force and displacement is 180 degree. So, if I am applying a force here and displacement is in this direction, force is here, displacement is here. Okay, no? Just now I told, if there is a component of force opposite to the direction of displacement. Now, force is acting suppose in positive x direction, displacement is in negative x direction. Okay, no? So, what type of work will be done? Negative work done, na? The answer for this is negative work done. What type of work is done? You have done negative work because angle is 180 degree. Let us move to next question number 5. A boy pushes a wall. A wall means stationary, no? Yeah, a boy cannot push the wall. A boy pushes a wall with a force of 50 Newton for 20 seconds and a 50 Newton, let him apply 100 Newton to 50 Newton. But the wall does not move. If wall will not move, will there be displacement? There will be no displacement. When there will be no displacement, how much work will be done? work done will be 0. So answer for question number 5 is 0. Let us move to next question. I am on 6. Which of the following is not a unit of work? Now work done is force multiplied by displacement, dot product of force and displacement. Work done is a scalar quantity. All three, work, power, energy, all are scalar quantity. Newton meter, I am starting with 2. In SI, the unit for force is Newton. The unit for displacement meter, 1 Newton meter is called joule. They are asking you is not a unit of work. So first you take what are the units of work. Then SI, the unit will be Newton meter or joule. Fourth you see erg. In CGS system, if you take the unit for force dyne and displacement centimeter, then 1 dyne centimeter will be known as erg. So 1, 2, 4. These 3 are the units for work done. Remaining only one is there, number 3, watt. It is the unit for power. 1 joule per second is known as 1 watt. So answer for this, not a unit of work, answer will be watt. Clear to you? Let us move now to question number 7. What is the work done by gravity when an object falls vertically downward? Now you see, gravitational force is acting downward. The force mg is acting downward. And displacement is also downward. The work done by gravity is positive because theta is 0. But if any external agency, suppose you are holding a book and slowly you are moving it downward, so you are applying force upward and displacement is downward, work done by you is negative. But work done by gravity, when object is falling downward, will be positive. So here, work done by gravity, when an object is falling downward, is positive work. Let us move to question number 8 now. A porter lifts a 15 kilogram suitcase. You have a porter. He is lifting a 15 kilogram suitcase from the ground to a height 2 meters. What kind of work does he do? Now, when porter is lifting the body, he is facing resistance. Gravitational force will be telling to porter, hey, where are you taking? Keep it down. Am I right now? A man forcibly will be taking it up. He is facing resistance. Work done will be positive now. Okay, no. So here they have given you what kind of no work because gravity acts downwards, negative work because it lifts against gravity, positive work against gravity, 0 work since it is a vertical motion. So when he is lifting it vertically up, he is applying force in upward direction. Displacement is also in upward direction. Angle between applied force by porter and displacement is 0. Angle is 0. So work done is positive. The porter, how much work he will do? mgh. Directly you can also calculate here. 15 into 10 into 2. Okay, no? Directly 300 joule you can say. Okay, no? positive work against gravity. Answer here number 3. Tell me, did you understand it clearly? Now, I move to question number 9. A stressed bow has stored energy. What form of energy is this? Now, here they have directly come onto potential energy. The capacity to do work by any agency, external agency, by you, is known as energy. Mechanical energy you have considered of 2 types, potential energy and kinetic energy. The easiest one is kinetic energy. You will tell why. The energy possessed by any body, if it has inertia due to its motion, is known as kinetic energy. You know, motion itself is a very vague term. In kinematics we have learned. Okay, no? If you want to talk about rest or motion, first you will have to consider any inertial frame of reference. It may be possible that a body may be at rest in one inertial frame of reference and may be moving in other inertial frame of reference. Many examples I have quoted. With respect to a co-passenger, a person who is sitting in a moving train, he is at rest. But with respect to a person who is standing on ground or on platform, that person is in motion. The kinetic energy, certainly whenever we want to talk, we will have to talk about first a frame of reference. But usually we are talking the motion with respect to earth. Anything which is moving on earth, with respect to earth, you will consider it will have kinetic energy, because any body we talk, it will have some mass. So I told you, any body which has inertia and which is moving in any inertial frame of reference, it will have kinetic energy, and only one formula you have for kinetic energy, half mv squared. Potential energy is not so easy. There will be 2 things, 2 distinct definitions of potential energy. One, potential energy of a particle. A particle means which has no dimension, no volume, total mass is assumed to be concentrated at one point, and that point is considered to be center of mass. Completely you are neglecting the dimension of physical system. Then potential energy of the particle will be due to its position in a field. If suppose a particle having mass m is situated in a gravitational field, it may have gravitational potential energy. If it is a charged particle is situated in an electric field, it will have electrostatic potential energy. Clear to you? The first definition is potential energy due to its position in a field. In that category, the most famous formula you have, minus capital G capital M small m by R, or roughly we are using mgh. If a body is situated at a height h having mass m, its potential energy mgh. If it is at a height h from the ground, it is roughly, it is not a correct formula. At the end, if time will be left, I will be telling you why mgh is an approximate formula. When a small h is neglected in comparison to radius of earth, then only you can use this formula. So suppose you are lifting a body to a height of 1 meter, 5 meter, 10 meter, 50 meter, 100 meter, then it's okay, because these distances can be neglected in comparison to radius of earth. So first concept related to potential energy is it is energy possessed by any particle due to its position in a field. If I have a mass in gravitational field, if I have a charged particle in electric field, if I have a nucleon, nuclear field, it must be situated in a field. If it is situated in a field-free space, any mass which is situated in field-free space where there is no gravitational field, it will not have any potential energy. Okay, no? Then in that way, if I am taking a field-free space, will any spring-based instrument will work? Yes, it will work. It means that potential energy may have some other concept also. The second concept or second definition, actually beta potential, if you see dictionary, it means hidden. The energy hidden in the configuration of a physical system is known as potential energy. Dictionary meaning. Potential, we say no, my all children have very high potential. IIT is a very simple exam beta. All of you recognize your potential. Okay, no? The moment you will be recognizing your potential, IIT is a very, very simple examination. You will certainly compete and you will get very good rank. Only you have to identify your potential and you will have to do work under proper guidance. Clear to you? The energy hidden in the configuration of a physical system means now particle concept you will not have to consider. There must be volume of the system, because now the energy which is hidden in the configuration of physical system will be known as potential energy. The best example is you take a spring. Already you know, if you stress the spring by a distance x, potential energy equal to half k x square. K is spring constant or force constant. You know that formula for potential energy you are obtaining by assuming energy hidden in the configuration of a spring. Clear to you? So here, okay, because we are doing worksheet, so in too much detail I can't explain to you. Just let us take this answer. A stressed bow has stored energy in it. What form of energy is this? Now, where is capacity to do work? Where is this energy? This energy is hidden in the stressed bow. Because you have to stretch it, you have to do mechanical work against molecular force of attraction. Your work done is stored in the stressed bow. So, what form of energy is this? Potential energy. I have told you two completely different concepts related to potential energy. If you have a particle, then energy will be, potential energy will be energy due to its position. But if you have dimension of the system, the energy hidden in the configuration of system is known as potential energy. So, I know now all of you have understood. Answer will be number 2, potential energy. And basic concepts, so nicely selected questions we are doing now, okay, no, that your basic concepts will be completely clear. Now, let us move to question number 10. A body is falling freely under gravity. Which of the following remains constant during the fall? Okay, no. Now, when body is falling, conservative force, gravitational force is a conservative force. When body will fall, its kinetic energy will be going on increasing because velocity will be going on increasing because acceleration due to gravity is acting in downward direction. And when kinetic energy will be increasing, potential energy will be decreasing. When a body is falling under gravity from certain height, then what will happen? Suppose you are dropping it from height h. As it will move downward, its displacement from ground is going on decreasing. So potential energy is decreasing. And because a small g is acting downward, so its velocity is going on increasing. Means kinetic energy is increasing, potential energy is decreasing. Potential energy plus kinetic energy will remain constant. Right? So they are asking you, which of the following remains constant during the fall? Our speed can't remain constant. Why? Because there is acceleration due to gravity. When speed is not constant, then kinetic energy will not remain constant. And when kinetic energy will not remain constant, potential energy will not remain constant because total mechanical energy remains constant. Answer here, total mechanical energy. Is it clear to you? If you understood this, then let us move to question number 11. Which of the following is an example of negative work? Negative work, in the beginning of this class I told you, the angle between force and displacement must be in the second or third quadrant excluding 90 degree and 270 degree, or there should be a component of force opposite to the direction of displacement. So which of the following is an example of negative work? Lifting a book upward. Now they are not telling who is doing work. If I am lifting a book upward, the work done by me will be positive. Why? For lifting the book, I am applying force in upward direction. And displacement is also occurring in upward direction. So work done in lifting a book upward is positive. A person pushing a stalled car, he is pushing. Car will move along the direction of push. Again, force and displacement are occurring in the same direction, so work done is positive. Number 4, a ball freely falling under gravity. Here one thing is there. If ball is freely falling, then again gravitational force is acting downward and displacement is acting downward. Work done by gravity is positive. Only one thing is left. Friction acting on a sliding object. If you take a body and this body is sliding in this direction, then frictional force will act in this direction. So force due to friction will be acting opposite to the direction of displacement. Am I right? Angle will be 180 degree. The work done by frictional force on the body will be negative. So answer for this question will be number 3. Clear to you? Let us move now to question number 12. When a body is raised to a certain height, it gains energy due to its motion, due to its shape, due to its position, due to its temperature. when you are lifting a body up, you are considering body as a particle. And I have told you, if a particle will have some position in gravitational field, it will have potential energy. Potential energy is the energy possessed by a body due to its position. So, when a body is raised to a certain height, at a certain height, it will have potential energy due to its position. The answer here will be its position. Clear to you? Let us move now to question number 13. Which of the following devices converts electrical energy into mechanical energy? If you take guaranteed electric motor, if you will take bulb, you are getting light energy, na? So electricity, electrical energy is converting into heat energy, light energy. Okay, you are considering all other. In these four, electric motor, there you are doing mechanical work, either in lifting water from a well. Okay, in many houses, sump will be there and they will be lifting water from there to upper floor with the help of electric motor. The electric motor converts electrical energy into mechanical energy. Answer number 2. Number 14 now. What happens to the kinetic energy of a body if its velocity is doubled? I have told you, kinetic energy has only one formula. So it is easy. Potential energy has so many formulae. Okay, no, but kinetic energy has only one formula, that is half mv squared. So kinetic energy equal to kinetic energy half mv squared. So I am taking K1, assuming mass is constant. So kinetic energy is half mv squared. Now I am taking K2, half m. They say your velocity is doubled. So 2v squared. You take K2 by K1, half mv squared 4 by half mv squared cancelled, 4, K2 equal to 4K1. Clear to you? Answer, it will become 4 times. In a simple way, every step I am showing you, so my every child will be understanding. Clear to you? I can say directly to you, velocity is doubled, kinetic energy is proportional to v squared, it will become 4 times. But no, I am showing you mathematically by using the formula. Clear to you? If you understood this, then move to question number 15 now. Which of the following is not a form of mechanical energy? Kinetic energy, gravitational potential energy, elastic potential energy, sound energy. Mechanical energy, whenever we are talking about, actually, truly speaking, gravitation chapter we are studying in mechanics, actually it is entirely different. Like electricity, sound, we people have kept different chapters. Actually, for gravitation also we will have to keep entirely a different unit. As for heat, light, sound we have kept, no, for gravitation also we should keep. Okay, no? But anyhow, it is not that much developed. We don't have much knowledge about gravitation. We are assuming capital G to be constant, but now people are finding that capital G is also not a constant quantity. Okay. What is the origin of gravitational force? It is still a mystery. Okay, no. But anyhow, here if you take in a general way, then kinetic energy, elastic potential energy, gravitational potential energy, all you are taking in the same category. They are asking you, is not a form of mechanical energy, will consider sound energy. So here your answer will be sound energy. Number 16 now. In a force versus displacement graph, the graph is a horizontal line. We are plotting a graph. You know that area of force displacement graph gives you work done. So I am taking displacement here and force here, and they say you force is, the graph is a horizontal line, force is constant. What does this tells you? Displacement is 0. No graph you see. Displacement is going on increasing. Work is not being done. Work is being done. Why work is being done? Because there is a constant force. When force is constant, then work done is simply F into S. Constant force is acting. Directly they say you in the question, force is constant, then constant force is acting. Question itself gives the answer. Acceleration is increasing, fourth they say. Acceleration will be increasing, force equal to mass into acceleration. Guaranteed then force should be increasing. Then only fourth will be the correct answer. F directly proportional, A directly proportional to F. The answer here, which is already there in the question, is number 3, that force is constant. Clear to you? Now, let us move to number 17. If the force versus displacement graph is a straight line from the origin and sloping upwards, I am taking a graph. On x-axis I have taken displacement, on y-axis I have taken force, and it is sloping upwards. It is starting from origin. As displacement is increasing, force is also going on increasing uniformly because slope is constant. Right? The force is increasing uniformly with displacement. Force is constant. No. Force will be constant if graph will be a straight line parallel to displacement axis. No force is acting. Then F must be 0. The object is at rest. Object will be at rest when displacement is 0. Directly your answer will be number 1. The force is increasing uniformly with displacement. Clear to you? Now let us move to question number 18. In a force versus displacement graph, the force decreases linearly from 10 Newton to 0 Newton, displacement of 5 meter. So I will plot a graph. Here 0, here I am taking displacement, here I am taking force. Let us take this as 10 Newton. They say you force decreases linearly from 10 Newton to 0 Newton. So 10 Newton to 0 Newton. See, this is 0. It becomes 10 Newton to 0 Newton. For a displacement of 5 meter, this is 5 meter. What does this represent? Constant negative force, work done is negative, variable force, work done equals area of triangle under the line. I told you, work done will be given by the area of force versus displacement graph. It's a triangle. Half into 5 into 10, 25 joule, that is work done. Just area of the triangle. They have not asked you how much work done. But simply area of the graph you take, it will give you work done. Force is variable. But here, because it is continuously decreasing, if force is variable, then I told you that work done will be integration F dot ds. That is the best technique for solving the problem for calculation of work done if force is variable. Here, your answer is variable force work done equals area of triangle under the line. Now, let us move to next question. I am now on number 19. A body gains 25 joule of kinetic energy. Kinetic energy 25 joule. Mass they have given you 2 kilogram. What is its final speed if it is starting from rest? Initial velocity is 0, means it doesn't have kinetic energy. And it is gaining 25 joule of kinetic energy. So 25 joule will be equal to your formula for kinetic energy is half mv square. So 25 equal to half mv square. 2 cancel, v square 25 v 5 meter per second. Answer number 1. Understood now? Answer is velocity of the body acquired will be 5 meter per second. Now move to question number 20 now. A body has 0 kinetic energy and 0 potential energy. No potential energy, no kinetic energy. Kinetic plus potential is 0, total mechanical energy is 0. Okay, which of the following must be true? The object is at rest at ground level. Slight doubt I have. The object is moving with constant speed. No. If object is moving with constant speed, it will have kinetic energy. The object is at maximum height. Maximum or minimum are relative term. Sentence itself is meaningless. What do you mean by maximum height? So it is also a wrong statement. Object is falling freely. If object is falling freely from certain height, it will have kinetic energy as well as potential energy. So, benefit of doubt, because if a body is at ground level, then also it will have potential energy, and that is equal to minus capital G capital M small m by R. It depends upon reference level. Yes, potential energy is a scalar quantity, but to express any scalar quantity, we also need a reference level. A scalar physical quantity does not mean that it has magnitude only. India had given the concept of 0 to the world. What is the meaning of 0? Okay, no? 0 is a reference level to express a physical quantity. 0 does not mean 0. Right now? If I am talking about potential energy and its position, if a body is kept on the surface of Earth, then with respect to center of Earth, it will have potential energy. If time will be left, I will be showing you this. And due to this only, my MgH is not a 100% correct formula. Right? But here, roughly, if I have to pick one answer, correct answer among these four, then I will be taking object is at rest at ground level. Since object is at rest, pre-assumed some inertial frame of reference they have considered. At ground level means your reference level they have taken as ground level. So its potential energy is 0 because it is at rest. So its kinetic energy is 0. Answer, if I have to select out of these four one, I'll be taking number 1. Now, let us move to next question number 21. A body of mass 2 kilogram. They have given me mass as 2 kilogram. Slides down a frictionless inclined plane from a height of 5 meter. So this is an inclined plane. Let us take angle of inclination theta. It is sliding down from a height of 5 meter. Object has started from here. What will be its speed at the bottom? Correctly, if you want to do, then you will have to take this length L. Whether if I use conservation of energy, potential energy will be equal to kinetic energy. Directly I will say mgh equal to half mv square. V I can calculate. But I am showing you here. So body is sliding here. This is the body. Here is mj. In this direction force is mg sin theta. Okay. So acceleration in this direction is g sin theta along the inclined plane. Right? Now, this is L. S equal to half a t squared. Speed, so v square equal to 2as. V under root 2a. S is L. So it will be 2 a is g sin theta into L. Now sin theta will be equal to, if this one I am taking as h, the sin theta will be h by L. H equal to L sin theta. So this will become L sin theta, you will take as h. 2gh. This is velocity. If you take kinetic equal to potential, also same formula you will get. mgh half mv squared, m cancel, v squared 2gh, v equal to under root 2gh. C. Both are correct now? First one is better. You should remember this technique. Under root 2gh. So how much v will be equal to? Under root 2. G let us take 10. H is 5. So 10 into 10. 10 meter per second. Answer number 2. Understanding now? So answer for this question is 2 under root 2gh, 2 into 10 into 5, under root 10 into 10, 110 left. Answer 10 meter per second. Let us move to now question number 22. A pendulum swings to a maximum height. I have a pendulum. And it is swinging to maximum height, and this height they have given you 0.4 meter. So what will be its potential energy? mg into 0.4. Simple. Now they say at what height is its kinetic energy is equal to its potential energy. Simple. Verbally we will do. Total mechanical energy will remain constant, no? At any point, wherever will be the bob of simple pendulum, its total mechanical energy will remain constant. It has maximum potential energy mg into 0.4 joule if you are taking in SI. Now, we want kinetic and potential should be equal, means half energy should be potential, half should be kinetic, then these two will be equal. Yes or no? Understanding me now? Half potential energy and half should be kinetic energy, total energy constant. अब total energy is mg 0.4. Half of that will be mg 0.2. Half of 0.4 is 0.2. They are asking you at what height kinetic equal to potential, the 0.2 meter. Because at 0.2 meter, potential energy will become half. The remaining half potential energy will convert into kinetic energy. So answer, directly I can take 0.2 meter, because at a height of 0.2 meter, your potential energy will become half. And remaining half potential will convert into kinetic, because total mechanical energy remains constant, so potential energy will become equal to kinetic energy. Clear to you? Now, let us move to question number 23. Two objects A and B are moving. Okay, I have two objects A and B and they are moving. Object A has twice the mass. So MA is twice the mass of B, twice the mass of object B, but only half kinetic energy. So kinetic energy A is half of kinetic energy B. Which of the following will be correct? Which is moving faster? Speed. They are talking about the speed. We know kinetic energy equal to half mv square. This is the formula. So what we do, because they are trying to compare velocity, so I will take kinetic energy 1 and 2. The kinetic energy here, from this what you say? Kinetic energy of A by kinetic energy of B equal to 1 by 2. Now kinetic energy of A, half MA VA square, half MB VB square, 1 by 2. Half cancel. MA they have given you 2 MB. So you will have 2 MB VA square by MB VB square. This is equal to 1 by 2. MB cancel. So you are getting VA square by VB square 1 by 4. So we want VA by VB. VA by VB equal to 1 by 2. So what you are getting? VB equal to 2VA. VB is moving faster. VB has velocity twice the velocity of A. Let us check now. Object A is moving faster than B. No. Object B is moving at the same speed as A. No. Object B is moving 2 times faster than A. What have you obtained? You have obtained VB equal to 2 times of VA. So, your answer will be number 3. Object B is moving 2 times faster than A. Okay? It is moving 2 times faster than A. Answer is number 3. Object B is moving 2 times slower than A. Already we got the answer. 4th is wrong. 1, 2, 4. These 3 options are wrong. Option 3 is correct. Let us move to next question. You have now 2 objects X and Y. So, I have 2 objects X, Y. Have the same momentum. So, it is P and it is P. But different masses. So, MX, MY. Which of the following statement is correct about their kinetic energy? Which will have greater, the object with greater mass has greater kinetic energy and all. So let us take kinetic energy formula. Kinetic energy is half mv square. Am I right? Now, you just, what you do, multiply by m and divide by m. It is m square v square, means p square by 2m. Am I right? They say you, from here you see better, kinetic energy equal to p square by 2m. Now what they say you? Linear momentum of x is equal to linear momentum of y. Means p is same. Means p squared is same. 2 is a constant quantity. So what you are obtaining from here? Kinetic energy is proportional to 1 by m. Means kinetic energy for this particular problem is inversely proportional to mass. So if you take here, you have kx by ky will become my by mx. Now, the object with greater mass has greater kinetic energy. You see, from here you can directly say, if mass is more, kinetic energy is less. So, the object with greater mass has greater kinetic energy is wrong. The object with the smaller mass have greater kinetic energy. No need here, directly from here answer you will be getting. They say object with a smaller mass, if m will be less, k will be more. The object with a smaller mass have greater kinetic energy. Both have same kinetic energy since momentum is equal. Wrong answer. Kinetic energy is not related to momentum. Kinetic energy is directly related to linear momentum. You have seen here. So for this question, answer is number 2. Clear to you? Let us now move to next question. 2 objects A and B. I have 2 objects A and B. They are moving such that momentum of object A, momentum of object A equal to 3 times momentum of object B, and kinetic energy of object A, is 1/4 of kinetic energy of B. 1/4 the kinetic energy of object D. They are asking you ratio of masses. You take here, from here you are getting kinetic energy of A by kinetic energy of B equal to 1/4. Yes, kinetic energy of A divided by kinetic energy of B equal to 1/4. And just in the previous problem, I have derived kinetic energy equal to Pa squared by 2m. Okay, no? So, kinetic energy of A will become Pa squared by 2ma by Kb. Pb squared by 2mb is 1/4. 2 cancelled, or Pa squared is, okay, let it be Pa squared by Pb squared, and here it is Mb by Ma is 1/4. Clear to you? Or here Pa squared. Pa squared is 9 Pb squared by Pb squared. They are asking you ratio of masses. Mb by Ma is 1/4. Pb squared is cancelled. So, you are getting 9 Mb by Ma is 1/4, or Ma by Mb equal to 36/1. They are asking you ratio of masses. So, you got Ma is to Mb equal to 36:1. Answer is number 1. Is it clear to you? Understood? Answers of all the questions? Perhaps only 25 questions would be there. Yes, it is fully completed and time is also over. Yeah, complete worksheet 3 we have completed. Again, next Saturday we will be doing, before when you will be coming, the 4th and last worksheet number 4. Okay, thank you for today. Have a nice day, and I hope that all 25 questions easily, clearly with concept you people have understood. Thank you again.
Good morning, students. So last time we have discussed quadratic equation, and today we will be discussing about sequence and series, right? I hope you have got the worksheet and you have done the questions. So let's discuss the worksheet. Okay, let's start with the first question. What is the first question? If the sum of n terms of an AP is given by Sn equal to 3n square plus 3n plus 2n square, then the common difference of the AP is what, right? So I have told you there is a shortcut for this also. If Sn, I think you must be knowing this shortcut, right? Apart from shortcut also we'll do this question. So if Sn is an square plus bn, right, then I can say the common difference will be equal to 2a, right? That is twice of 2 times of coefficient of n square. 2 times of coefficient of what? N square, right? So in this case, what is the coefficient of n square? 2. So it will be 2 into 2, which is how much? 4. So the answer is what? 4, right? So please remember this fact. Also, if somebody doesn't know this, right, then what we can do? Then we can find S1 first, right? What will be S1? 3 plus 2, which will be what? 5, right? Then I'll find S2. S2 will be how much? For S2, I'll write 3 into 2 plus 2 into 2 square, right? So it will be 8 plus 6 will be how much? 14, right? It will be how much? 14. And S2 minus S1 will be equal to what? T2, correct? So what I'll do? I'll minus 14 minus 5 will be equal to T2. So it means T2 is equal to what? 9, right? T2 is equal to what? 9. And S1 is nothing but T1. Right, S1 is nothing but T1. So can I say that the common difference will be equal to T2 minus T1, which will be 9 minus 5, which will be what? 4. Right, it will be how much? 4. So D will be equal to 4. So this is one shortcut method. If Sn is equal to an square plus bn, then the common difference will be equal to twice of coefficient of n square. Right, I hope it is clear to everyone. Right, let's go to the next question. If the third term of a GP is 4, then the product of the fifth 5 terms is what, right? Third term of a GP is what? 4. Right, so let's assume the terms to be what? AR square, AR cube, and AR to the power 4, right? So third term, it means that AR square will be equal to what? 4. According to them, AR square will be equal to what? 4. And the product of first 5 terms, right? If I multiply all of them, so what I'm going to get? AR, right? AR square, AR cube, AR to the power 4 is equal to what, right? So if I do that, I'll have A 5 times, right? I'll have A 5 times. So I'll have A to the power 5, and then R is 1 plus 2 plus 3 plus 4, right? So it will be A to the power 5 into R to the power 10. It means AR square to the power 5, right? AR square to the power what? 5. And what is AR square? 4, right? So what can I say? It will be equal to 4 to the power 5, right? It will be equal to what? 4 to the power 5. So the correct option in this is what? Option 3, right? Correct option is this is what? Option 3. Okay, I hope this is clear to everyone. Then third question. If 9 times the 9th term of an AP is equal to 13 times the 13th term of the AP, right? Then the 22nd term of the AP is what? Then the 22nd term of the AP is what? So what they are saying, 9 times of T9 is equal to 13 times of T13, right? What is 9 times of T9? So 9 into A plus 8D is equal to 13 into A plus 12D. Right, 13 into A plus 12D, right? So what can I say from here? 9A plus 72D is equal to 13A plus 13 12 is 130, 156, right? 156D, right? So can I, if I shifted everything on this side, I will be getting 4A, right? 13A minus 9A is what? 4A, right? And 156D minus 72D, 156 minus 72. So it will be how much? 6 minus 2 is, so 84D, right? 84D will be equal to 0, correct? 84D will be equal to 0. If I take 4 common, I will be getting A plus 21D will be equal to 0, correct? A plus 21D will be equal to what? 0. So, can I say A plus 21D will be equal to 0? Right? A plus 21D is equal to 0. And if A plus 21D is 0, what they are asking? T22, right? T22. What is T22? T22 is nothing but A plus 22 minus 1D, right? A plus, which is how much? A plus 21D, which will be 0, right? Which will be 0, right? So the correct answer for this is what? Option A, right? Option A, which is 0, right? I hope this is clear to everyone. Next question. I think these 3 questions, whatever we have done, this kind of question was there in your worksheet also, right? If you have done in the class, right? They were there in the worksheet also. Okay. Now next question. If X, 2Y and 3Z are in AP, where the distinct numbers X, Y and Z are in GP, then the common ratio of the GP is what, right? So we know that if A, B, C are in AP, right? I have told you last time also that 2B will be equal to what? A plus C. 2B will be equal to what? A plus C. This is the result, right? You can remember in this way also or in this way also that B is equal to A plus C by 2, right? You can also remember in B equal to A plus C by 2. Okay, anyway. So now, here what is B, right? If I compare, I will be getting here that twice of middle term. What is the middle term here? 2y, right? Is equal to X plus 3z. Is equal to what? X plus 3z, right? And the distinct numbers X, Y, Z are in GP. X, Y, Z are in GP. So I can say let X be equal to A, Y be equal to AR, and Z be equal to what? AR square. Right, AR and AR square. So this will be what? It will be equal to twice of AR is equal to A plus AR square. Right. Now A and A will be getting cancelling out. So I'll be having 4AR is equal to A into 1 plus R square. Right, 4AR. Now A and A will get cancelled. So you will have finally, right, you will have R square minus 4R plus 1 equal to 0. Okay, acha, I think we have this, there will be a 3 also here, right? So it will be 3. So it will be 3R square minus 4R plus 1 equal to 0, right? Now if you solve this quadratic, right? If you solve this quadratic, what you will be getting? You will be getting 3R square minus 3R minus R minus plus 1 is equal to 0, right? So you can take 3R common, we'll have R minus 1, R minus 1 equal to 0. So I can say R is equal to 1 by 3 or R is equal to 1, right? R equal to 1 by 3 or R equal to 1. But if R equal to 1, right? R equal to 1, then it's not an option first of all, and then X, Y, Z will be equal, right? And they are saying they are distinct numbers. They are saying it is distinct. So that is why R cannot be equal to what? 1. So the correct answer for this is what? R equal to 1 by 3. Right? The answer for this is what? R equal to 1 by 3. And that is option 2. Right? That is what? Option 2. Okay? I hope this is clear to everyone. Next. Give me a minute. Okay, next question. If in an AP Sn equal to Qn square, Sm equal to Qm square, and Sr denotes the sum of R terms of the AP, then Sq equal to what? Right? Then Sq equal to what? So what I have done? They are saying Sn is equal to Qn square, right? Sm is equal to what? Qm square, right? And what they are asking? Sq. For Q, what I'll do in place of M and N, I'll write Q. It will be Q into Q square, which will be how much? Q cube. Right? It will be how much? Q cube. Right? So the answer will be what? Option 3. right? I hope I'm clear with this. Just a minute, the AC is acting here. Next, let Sn denote the sum of first n terms of an AP. If S2n is equal to 3Sn, right? S2n is equal to S3Sn, then S3n upon Sn is equal to what, right? They are clearly saying it is an AP, right? They are clearly saying it is an AP. So what you do, okay, you write n equal to 1, right? It will not matter. So you put n equal to 1. If you put n equal to 1, what you will be getting? You will be getting S3 is equal to 3, sorry, you will be getting S2. You will be getting S2. S2 is equal to 3 times of S1. Right? S2 equal to 3 times of S1. What is S2 sum of two terms? That is S1 plus, T1. S2 will be what? S2 will be T1 plus T2. Right? It will be equal to 3 times of T1. Correct? So can I say from here that T2 is equal to twice of T1? Right? T2 equal to twice of T1. What is T2? A plus D. It's an AP, right? So A plus D. And what is this? 2A. So can I say from here D is equal to A? Right? Can I say from here that D is equal to A? Now what they are asking? S3 upon, they are asking S3 upon S1, right? What is S3? S3 is what? Sum of 3 terms. So it will be 3 by 2, right? 2A plus 3 minus 1 into D, right? And S1 is nothing but A. And S1 is nothing but A. So I can write it to be equal to 3 by 2 into 2A plus 2D, right? Divided by what? A. But we have D is equal to A from here, right? So I can plug it in, and what will I get? 3 by 2 into 4A divided by A. A and A will be cancelling, so I will be getting 6. Right, so the answer will be what? Option 2. Right? The correct option for this will be what? Option 2. Okay? I hope this is clear to everyone. Question 6. Next. The length of the 3 unequal edges of a rectangular solid block are in GP. Right? If the volume of the block is 216 centimeter and the total surface area is how much? 252 centimeter square, then the length of the longest edge is equal to what? Okay. So first let's draw a rectangular solid block, basically a cuboid, right? Basically what they are asking us to, what they are asking? Cuboid. Right? So this is a rectangular solid block, right? So this is a long. So what I was saying, let this be A, right? This be AR and this be what? AR square, right? AR and AR square, correct? So now we know they have given that volume is equal to how much? 216, and TSA, total surface area, is given to be how much? 252, right? Then the length of the longest side. What is the volume? Volume of the cuboid is length into breadth into height, right? It is given to be 216, and total surface area is how much? Twice of length into breadth plus breadth into height plus L into H is equal to what? 252. Correct? Okay, so we can divide this 2 with this, and what I will be getting? I will be getting it to be 126, right? 126. Okay. Now they are in GP, so I can write here A, right? AR and AR square equal to what? 216. Correct. So I can say AR whole cube is equal to 216. Right? What I can say? AR whole cube is equal to what? 216. So can I say that A into R will be equal to 6? Right? A into R will be equal to what? 6. Okay. Now we know length into breadth plus breadth into height plus length into height is how much? 126. So let's see what do we get. So what I will be getting? length is A into AR plus AR into AR square plus A into AR square is equal to how much? 1 to 6. Right? From everywhere, if you can see here, A square is there, A square is there, A square is there. So I can take A square common, and from here I'll be having R plus R square, right? Sorry, R cube, R square and R cube. It is equal to what? 1 to 6. Right? In fact, I can take R also common, right? I can take R also common. So it will be becoming A square R 1 plus R square equal to 1 to 6. And now know AR equal to what? 6. Right? AR equal to what? 6. So if I square this, I'll be getting A square R square equal to 36. So A square R will be equal to what? 36 by R. Right? It will be equal to what? 36 by R. If I plug in this value here, right, what I'll be getting? I'll be getting 36 by R into 1 plus R square equal to 126, right? It will equal to what? 126, correct? Now, you can solve this quadratic, right? You can solve this quadratic and get the value of R, right? You can get the value of this R, and then from there you will get the length of the longest side. Okay, once you get R, you can plug in and you can get A also. Okay, I hope it is clear to everyone. Okay, next. 8th question. The middle term in the following arithmetic sequence is what? Right? The middle term in the following arithmetic sequence is what? So what they have done, they have given us the last term, right, Tn, and they have also given us A, right? And we can find the common difference, right? We can find the what? Common difference. So what will be the common difference? Common difference will be how much? 16 minus 20, which will be minus 4. Right? Common difference will be how much? Minus 4. Right? Now what they are saying? We have Tn. So Tn is equal to what? Tn is equal to A plus n minus 1 into D. Right? What is Tn? Tn is minus 176 is equal to what is A? 20 plus n minus 1 into D. D is how much? D is minus 4. Right? D is how much? Minus 4. So if it comes on this side, I'll get minus 196 is equal to minus 4 into n minus 1. Right? N minus 1. Okay. So if I divide this, what I'll get? 4. So I'll get 49 is equal to what? N minus 1. Right? 49 is equal to what? N minus 1. Correct. So n will be equal to what? N will be equal to what? 50. Right? N will be equal to how much? 50. If n is 50, so for the middle term, right? The middle term I can write 25. Middle term I can say T25. So T25 will be how much? A plus 25 minus 1 into D. Right? So what is A here? A is 20. This is 24 and this is minus 4. Right? 24 and this is minus 4. Correct. So it will be how much? 20 minus 96. Right? Which will be how much? 20 minus 96. So this will be minus 76. Minus 76. Right? So you can say the answer is minus 76. But they are saying the middle term. So minus 196 and minus 4, which is 49. It is also correct. Now n equal to 24. D is 24. And 20. This is going to be minus 6. The answer is minus 76, right? I don't know why it is not there in the option. Okay. Okay. One more thing is that the middle term can be the next term also, right? So after minus 76, there will be minus 80 also, right? So that is why it could be the answer 3 also, right? Okay. Next. If the first, second and the last term of an AP, first, second and the last term of an AP are A, B and 2A respectively, then its sum is equal to what? Right? Then its sum is equal to what? First, second and the last term of an AP, right? If the first sum is A, right, second term, that is A plus D is equal to B, right? And Tn is equal to 2A, right? Tn is equal to what? 2A. Then it's sum. Okay. So what I'll do, I know what is D. D is equal to B minus A, right? D is equal to what? B minus A. And what is Tn? Tn is nothing but A plus n minus 1D is equal to 2A, right? A plus n minus 1D is equal to 2A. So I'll get A plus n minus 1 into B minus A is equal to 2A, right? Okay. So if I do this, what I'll get? N minus 1 into B minus A is equal to A. So I can say n minus 1 is equal to A upon B minus A, right? N minus 1 will be equal to what? A upon B minus A. If I send this 1 that side, I will be getting A upon B minus A plus 1, right? B minus A plus 1. If I take LCM, right, what I will be getting here? I will be getting A plus B minus A divided by B minus A, and A will cancel. So I will be having N is equal to what? B upon B minus A, right? N is equal to what? B upon B minus A. Now we have N, we have the first term and the last term also. So I can say Sn is equal to what? N by 2 A plus L. So what is N? N is B upon 2 into B minus A into A. What is A? A plus 2A. Right. So finally what I will be getting here? I will be getting 3AB upon 2 into B minus A. Right. 3AB upon 2 into B minus A, which is option 3. Right. Which is option 3. Okay. I hope this is clear to everyone. Next. This question I think was there in your worksheet also, an example. Let's understand this. One side of an equilateral triangle is 24 centimeter. The midpoint of its sides are joined from another triangle whose midpoints are in turn joined to form still another triangle, right? This process continues infinitely. The sum of the perimeters of all the triangle. First of all, you have to know what is the perimeter of the triangle. Perimeter of the triangle is what? 3A plus B plus C, right? A plus B plus C. But it is an equilateral triangle, right? They have given it's an equilateral triangle. So if it's an equilateral triangle, right? If it's an equilateral triangle, I can say the perimeter will be what? 3A, right? 3 into A. Okay. Now, see, this side is 24. Right, and this will be how much? 12. This is 12 and this is also 12, correct? Because they have joined the midpoint. Okay, and this angle is how much? It's for an equilateral triangle, so it is 60. This is 60, so this also has to be how much? 60 and 60, right? Correct? So can I say this side of the triangle is also 12 because it's an equilateral triangle. This small triangle will also be a what? A equilateral triangle, right? If it is 12, this is 12, this is 12, right? So this one will be what? 6, right? So inside one will be how much? 6. So what will be the perimeter, sum of perimeter, right? Sum of SP they want. So for first triangle it will be 3 times of 24, right? Because the first side is how much? 24, right? For the second triangle it will be how much? 3 times of 12. The third triangle it will be 3 times of 6 and so on. Right, and so on. Now, if you see very carefully, it's a GP, right? It's a GP with common ratio what? Half. Every side is getting what? Half of the previous one, correct? So it is what? Common ratio is what? Half. Okay, if it is there, then what can I say? I can sum of the GP. Sum of GP is what? Sn is equal to A upon 1 minus R. Right? A upon 1 minus R. What is A here? This is the first term. So I can say 3 into 24 divided by 1 minus half. Right? 3 into 24 divided by 1 minus half. What is 3 into 24? This will be how much? 6 into 24. Right? This will be how much? 6 into 24. And what is 6 into 24? It will be 144. Right? It will be how much? 144 centimeters. So the answer is what? Option 1. Right? For this question, the answer is what? Option 1. Okay. I hope this is clear to everyone. Right. Next, if TR denotes the rth term of a GP, right, and product of T1, T5, T10, T16, T21, T25 is equal to 512, then the value of its 13th term, right, 13th term. Okay, so what will be T1? T1 will be A. T5 will be how much? A r to the power 5 minus 1, which is 4, right? T10 will be how much? A r to the power 9, right? Then what it is? T16. T16 is how much? A r to the power 15, right? Then it is T21. T21 is how much? A into r to the power 20, and then T25 is A r to the power 24, right? This we have listed in terms of A and R, right? Now what they are saying, they have multiplied the terms. What they have done, they have multiplied the terms. So if I multiply all of them, right? So what I'll get? A I'll get how many times? 1, 2, 3, 4, 5, 6. So I'll get A to the power 6. Correct? The product is what? A to the power 6. And for R will be what? 4 plus 9 plus this is 15, right? Plus this is 20 and then 24. Right? Because the power get added. Whenever we multiply the power, we what get added. So it is, this is given to be how much? 512. Right? Now let's see what is 4 plus 9 plus 15 plus 20 plus 24. Right? So we can directly add them anyway. So if I add them, what is 4 plus 9? 13. 13 plus 15 is 28. 28 plus 20 is 48. 48 plus 24 is 72. Right? How much? So it is A to the power 6, R to the power 72 is equal to what? 512. Right? Now definitely there is 6 is the highest common factor of 6 and 72. So can I say A R square, 12 to the power 6, right? It is equal to what? 512, right? So I can say A R to the power 12 is equal to 512 to the power 1/6. And what is 512? 2 to the power 12. Sorry, it is not 2 to the power 12. It is 2 to the power 9. Right? This is how much? 2 to the power, It is 2 to the power 9 and this is how much? 1/6. So I can say it is 2 to the power 3 by 2. Right? 2 to the power 3 by 2, which is nothing but 2 root 2. Which is nothing but 2 root 2. And now what they are saying, the value of its 13th term, right? T13. T13 is nothing but AR to the power 12, which we have got here, right? Which we have got here. It is how much? 2 root 2. The answer for this question will be how much? Option 4, right? It is 2 root 2. Okay? I hope it is clear to everyone. Alright. Next. There are 4 numbers of which the first 3 are in GP, right? There are 4 numbers of which the first 3 are in what? GP and the last 3 are in AP, okay? Whose common difference is 6. If the first number and the last numbers are equal, if the first number and the last number are equal, then the numbers are. So directly if you see, check in the option, 2 and 12 are not equal. 8 and 8 are equal, so this could be the answer, right? Here also 3 and 18 are not equal, incorrect. 6 and 24 is not the answer, incorrect. So the answer is what? Directly option 2, right? Now let's verify what they are saying, right? There are 4 numbers of which 3 are in GP, right? So you can see that 8 and 2 and 8, right? Are they in GP? 8 and 2 and this, or you can say 8 minus 4 and 2, 8 minus 4 and 2. If you divide minus 4 with 8, you will get what? Minus half. And if you divide 2 with minus 4, you will get minus half. So it means they are in GP, right? The first 3 are in GP and the last 3 are in AP. So you can see that minus 2 minus minus 4 is how much? 6, and 8 minus 2 is also 6. So I can say minus 4, 2 and 8 are in what? AP. right? So all the conditions are met here, right? That is why the answer is what? Option 2. Correct? The answer is for option 2. Okay. Let's do the next one. 13th. The number of numbers lying between 100 and 500 that are divisible by 7 but not 21. That are divisible by 7 but not 21. So what is the first number which is divisible by 7 between after 100, right? After 100. So it is going to be 105. It is going to be how much? 105. Right? 105. Now, after 105, the next number will be how much? 112. 112. And for 500, before 500, the number will be how much? 497. Right? 497. Okay. So, how many terms are there? These are the numbers. These are the numbers. So on. These are the number which will be divisible by 7. Which will be divisible by what? 7. So, if I want to find n, right? So, I can apply the formula of Tn. Tn is equal to A plus n minus 1 into D. What is Tn? 497 is equal to A is 105 plus n minus 1. D is how much? D is 7. Right? D is going to be how much? 7. So, if I do 497 minus 105, I am going to get 293. 392 is equal to what? 7 n minus 1. Correct? If I divide this 7, I am going to get 56 is equal to n minus 1. So, n is going to be how much? 57. Correct? So, total number of terms which are divisible by just 7 in between 100 and 500 is how much? 57. Right? 57. Out of these numbers, some of the numbers will be divisible by 21 also, right? Some of this number will be divisible by what? 21 also. If they are divisible, then we don't need those numbers. Right? So we need to remove those numbers. How many numbers are there? Let's find out for 21. Right? But anyway, you can see 76 and 57 cannot come. Right? 76 and 57 cannot come. Now, how many numbers are there between 100 and 500 which are divisible by what? 21. Let's find out. So the first number will be how much? 105 only, right? Then if I add 21, right? If I add 21, it is going to be how much? 126 and so on. What will be the last number, right? What will be the last number? If I multiply it with 2, 4, 20, right? So last number 500 is there, right? I guess last number will be 21 into, if I do 2, so I'll get 420, right? 420. And if I add in this 21, so I'll get 441. Then if I add again 21, I'll get 462. If I add again 21, I'll get 483, right? I guess 483 is the last number, right? It is what? 483. Okay, and if I want to find out how many n are there, so I can say 483 is equal to 105 plus n minus 1 into d, right? So 483 minus 105 is equal to n minus 1 into 21, right? Now what is 83 minus 5? So 378 divided by 21 is equal to n minus 1, right? Now if I divide this, how much I will be getting? It is 1, I guess it is 18, right? It is how much? 18, right? 21 times 18 is how much? This, right? And now, so n will be equal to what? 19. N will be equal to what? 19. So out of this 57 terms, 19 terms are there which are divisible by 21 also. So to get the terms which are not divisible by 21, what I have to do? I have to subtract 57 from 21 from 57. Not 27, 19, right? So how much I will be getting? 57 if I subtract from 19, I think I will be getting 38. Right? So the answer is what? 38. Okay, I hope this is clear. 19 terms are there which are divisible by 21, but they are asking the terms which are not divisible by 21, right? Not the terms which are divisible by 21. Okay, I hope this is clear. Next, if TR denotes the rth term of an AP, right, and this is there, then the sum of its first 24 terms, right? Sum of its first 24 term. Okay, so what I can do? What is T1? T1 will be A. T5 will be how much? A plus 4D. Right? T15 will be how much? A plus 14D. T20 will be how much? A plus 19D. And T how much? 24. A plus 23D. Correct? If I add all of this, right, what will I get? I'll get 5A, right? Then 4 plus 14 plus 19 plus 23, right? So 4 plus it is how much? 4 plus 14 is 18, 18 plus 19 is 37, and 37 plus this is 3, I guess 60, right? 60D, yes. 60D is equal to how much? 75, right? Now I can take 5 common out of it. If I take 5 common, I'll be getting 5A plus 12D, right? A plus 12D is equal to how much? 75. So I can say A plus 12D will be equal to how much? Divide if I do, I'll get 15. Right? Now what they are saying, sum of its first 24 terms. They are asking S24. S24. Right? S24. S24 will be how much? S24 will be 24 by 2 first term plus last term. Right? So it will be 24 by 2 into 2A plus 24D. Right? So it will be how much? 24 by 24 into A plus 12D, which is 24 into how much it is? A plus 12D we have got it to be 15, right? It is how much? 15. So the answer will be how much? 24, 240. Right? 240 plus 120, right? So it is 360. Understood? The answer is what? 360. I think there is no, that is not there in the option, but the answer is T60. Right? Okay. Next question. If eighth term of an AP is 15, then the sum of, I think there is some error in this question, then sum of its eighth term is this, the sum of its what? I don't know. So there is some error in this question. So let's skip this question. The sum of all two digits odd number, right? So the first odd 2-digit number will be what? 11, and the last will be what? 99, sorry. Right? How much? 99. So n will be equal to how much? 99 minus 11, right? Okay. So I have to use Tn formula. I have to use the formula of Tn. Right? Directly, you don't know this formula right now. So I can say it's 11, then 13 and 15, then so on, right? So Tn will be equal to what? A plus n minus 1 into D, right? What is Tn we have? We have it to be 99 is equal to 11 plus n minus 1, D is 2, right? So 99 minus 11 is equal to twice of n minus 1. So 88 is equal to 2 of, so I can say n minus 1 equal to 44. So n is equal to 45. Right? N is equal to what? 45. Now what they are saying, sum of all the numbers. Now S45 will be how much? 45 by 2 into 11 plus 99. Right? 11 plus 99, which is how much? 45 by 2 into 110, which is 45 into 55, right? 45 into 55, right? So it will be how much? It will be something ending with 5, right? So you can do that and you can get the answer, right? I think it should be 2475. I'm not sure. Either it is option this or option this, right? But anyone is the right answer, right? Whatever is the multiplication of 45 into 55. Okay. I hope this is clear to everyone. It's a simple question. Next. if 3 plus 5 plus 7 up to 4 terms, so just like directly we can write down, right? It's what they're saying, 4 terms. So 4 by 2, right? 2a. What is 2a? 3 plus n minus 1. How many is there? 3 into d. What is 5 minus 3? 2. Right? Divide by 10 terms. Right? Up to 10 terms. So what they're asking in this is 3 plus 5 plus 3 up to 4 terms, and this is still 10 terms. I don't know, they have given some error here. N cannot be coming here, right? N cannot be coming because there is no n in this case. Right? They have not given anything about n. So there is no point in doing this question. Next, the Wth term of an AP is n and the Uth term is m. Its Pth term is equal to what? Right? Okay. So Wth term Tw is equal to what? N, and Tu is equal to what? M. What is Tw? Tw will be what? A plus W minus 1D is equal to what? N. And Tu will be how much? Tu A plus U minus 1D is equal to what? M. Right? What they are asking? Acha, if I subtract these two, right? If I subtract this two, right, I'll get the value of D, right? If I subtract this two, A and A will get cancelled, right? So what I'll be getting? W minus mu U into D. W minus U into D is equal to what? Is equal to N minus M, right? Is equal to N minus M. So I can get the value of D from here, right? D is equal to N minus M upon W minus mu, correct? And now after this I can find the value of A, right? After substituting this value here, right? I can get the value of A, and then they are asking Pth term. So Tp is equal to what? A plus P minus 1D, right? A plus P minus 1D. So just we need to put the value of A plus P minus 1, and D is how much? N minus 1 M upon W minus U, right? Upon W minus U. And what is the value of A? A value you can get it from here, right? You plug in, you will get the answer. Okay. Next, the nth term of a GP is 128. So A R to the power n minus 1 is equal to 128, and sum of its n term, okay, is 255. So n term is what? A into 1 minus r to the power n upon 1 minus r is equal to how much? 255. If its common ratio is 2, right? Its common ratio is how much? 2. Then its first term, right? First term is equal to what? So we don't know. We know the common ratio is how much? 2. Right? So I can say A is equal to how much? 128 divided by 2 to the power n minus 1. Am I correct? I'll put this value of A here. So I'll get 128 divided by 2 to the power n minus 1. Right? This will be 1 minus 2 to the power n divided by 1 minus 2 is equal to 255. Right? So from here, what I will get? I'll get 2 to the power 1 minus n minus 2. Right? Minus 2 is equal to 255 divided by 128. I'll get 128. Okay, now I'll send this to that side, right? I'll send this to that side. So what I'll be getting? 2 to the power 1 minus n is equal to 255 divided by 128 plus 2. Right? It will be 128 plus 2. And then what is this? 255 plus 256 divided by 128, right? So from here I can get the value of n. On comparison, I can get the value of what? N here. Okay, I hope this is clear to everyone. Next, the third term of an AP is 3, right? The third term of an AP is 3. What is the third term? A plus 2D. T3 they have given to be how much? 3. the product of its first 5 terms, right? Product of its first 5 terms equal to what? Okay, so they have given the third term of an AP is 3. I think they have done a mistake here. It has to be a GP, right? It can't be a AP because they're asking the product, right? So the product of first 5 terms, T1, T2, T3, T4 and T5, right? This will be equal to, for a GP, if you remember, the product of last 2 terms and this terms will be equal to this particular term, right? So this will be nothing but T3 to the power 5, right? This will be nothing but T3 to the power 5. So it will be how much? 3 to the power 5, which will be 243. So the answer will be what? 243, but provided this is not a AP, it is a GP. Right? This is a GP, this is not an AP. Okay. Next, the sum of integers from 1 to 100 that are divisible by 2 or 5, right? It's a question of set and also of AP. Okay, so how many numbers? The sum we need to find, right? We need to find the sum. So sum of all the numbers, right, which are divisible by 2, will be how much? So it will be 2 from 1 to 100, right? So 2 plus 4 plus 6, so on till 100. So on till 100. So how many terms are there? How many terms are there? 50 terms. So it will be how much? 50 by 2, right? 2 plus 100. Correct. So it will be how much? 50 into 51. Right? 50 into 51, which will be how much? 0, 5, 2, 5, 5, 0. Right? Sum of the numbers which are divisible by 2 is how much? 2, 5, 5, 0. Similarly, I can find out the numbers, sum of the numbers which are divisible by 5. So it will be 5 plus 10 plus 15, so on till 100. How many terms will be there? 20. So 20 divided by 2 into 5 plus 105. 100. So it will be 10 into 105. It will be how much? 1050. Right? It will be how much? 1050. These are the numbers which are divisible by 5. But the problem is there are some numbers which are repeated in both the series. Right? So it's like in set, if you remember, this is S2, right? And this is S5. Right? So these numbers are repeated. So we need to subtract the numbers which are divisible by both 2 and 5, which means it is divisible by 10. It will be how much? 10 plus 20, so on till 100. Right? So it will be 10 by 2, 10 plus 100. Right? So it is 10 into 55, which is 550. Right? So what I can say, the sum of the numbers, required sum S is equal to what? 2550 plus, right, 2550 plus 1050 plus 1050 minus 5550, right? 1050 minus 1550 is how much? It is 3600 minus 550, right? So it is going to be how much? 3050, right? It is equal to how much? 3050. Okay. I hope you understood this question also. Next, consider an infinite GP with its first term A and common ratio V. If C, I think it's sum. If its sum is, right? I think it's sum is 4 and the second term is 3 by 4, right? Sum of an infinite GP is how much? 1 upon A upon 1 minus V, right? It is equal to, they have given to be 4, right? And the second term will be how much? A into R, which is AV, is equal to 3 by 4. So can I say from here A is equal to 3 by 4 V? I can plug in this value in this, right? So if I do that, I'll be getting 3 by 4 V, 1 minus V is equal to 4, right? So I can say 3 is equal to 16V minus 16V square, right? So 16V square minus 16V plus 3 is equal to 0, right? Plus 3 is equal to what? 0. Correct. So what you will be getting here, 16 into 3 is 48. So 16v square minus 12v minus 4v plus 3 is equal to 0. Right. So I can take 4 common from here. If I do this, what will I be getting? What I will be getting here? 4v, right? 4v minus 3 minus 1. 4v minus 3 is equal to 0. So either v equal to 1 by 4 or v is equal to 3 by 4. Right? Both are the possibility. So v is equal to 1 by 4 or v is equal to 3 by 4. Right? So the answer for v we have got. Okay. I hope this is also clear to everyone. How many terms of the series 1 plus 3 square must be taken to, I think there is an error in this question, to mere, I'm not sure what it is written. Next, find the SS of GP whose first term is 28 and fourth term is 4 upon 49, right? We need to find sum of the infinite GP, I guess, right? So fourth term will be how much? AR cube. AR cube will be given as 4 upon 49 and A is 28. So 28 into R cube is equal to 4 upon 49, right? So this is 1 and this is 7. So I can say R cube is equal to 1 upon 7 cube. So I can say R is equal to 1 by 7. We have R and we also have A to be how much? 28. Right? So I can find this sum of the infinite GP. Right? S infinity will be how much? A upon 1 minus R, which will be 28 upon 1 minus 1 by 7. Right? Which will be how much? 28 divided by 6 by 7. Right? So 28 into 7 divided by 6. Right? So this will be divided with 3 and this is 14. So 98 by 3. Right? The answer will be what? 98 by 3. Okay. Next. Last question. The number of numbers lying between 81 and 1792 which are divisible by 17. Right? Which are divisible by what? 17. So the first number which is divisible by after 81, right, is going to be 85. Right? Then if I add 85, 17, I'll get 102 and so on. Right? Which one will be the last number? Right? Last number. So we don't know the last number yet. Right? So what I can do? I can just divide 1792 with 17. Right? And see what we are getting. So we'll get 1, right, and 92. 92 is like, I think it will be 1785. Right? The number will be what? 1785. Right? 1792, 1785. So how many numbers are there? We need to find out. So Tn will be equal to A plus n minus 1 into D. Right? Tn equal to what? A plus n minus 1 into D. What is Tn? 1785 is equal to 85 plus n minus 1 into D. D is 17. Right? So if I subtract this, I'll get 1700 is equal to 17 into n minus 1. Right? 17 into n minus 1. If I divide it, I'll get 100 is equal to n minus 1. So from here I can say n is equal to what? 101. Right? So the number of numbers which are divisible by 17 between 81 and 1792 is how much? 101. Right? It is how much? 101. Right? So I think this marks the end of the discussion. Right? I hope every question is clear. If you still have any doubt, then you can visit the center. Right? And there will be doubt faculties there from 2 to 5, and you can discuss with them. Okay? You can discuss with them and clear your doubts. All right? Thank you, everyone.